So today we are going to start trigonometry. In short, we are studying triangles. So triangles can be classified into two based on their interior angles. We have what we call the right triangle, or we call them the right angle triangles, and non-right angle triangles. Let us start from a right angle triangle. So for this right angle triangle, the longest side is the side facing 90 degrees. It's called the hypotenuse. Then this triangle has two angles, this angle and this. So if we are considering this angle here, let's call it theta. The side facing this is the opposite, while the third side is the adjacent. And you have to know the Pythagoras theorem from your elementary school. Suppose the opposite is A, the adjacent is B, and the hypotenuse is C. According to Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the two sides, a squared plus b squared. And that is what? Pythagoras theorem. Before I continue my class, this is trig 2. We've already done trig 1, but this summary of trig 1, then we'll continue. So they are actually what we call the trig ratios. They are 6 in number. So the acronym is the word SOHCAHTOA, where this S stands for the sine of the angle, this C stands for cosine of the angle, while this T stands for the tangent of the angle, shortened as SIN COSTAN. According to this acronym, it means sine of the angle we are considering in this case theta is the opposite to hypotenuse. Opposite to hypotenuse, that's A over C. While the cos of the angle is the adjacent to the hypotenuse. Adjacent to hypotenuse. While the tangent of the angle tan theta is the ratio of the opposite to adjacent. So opposite to adjacent, A divided by B. Then we have the inverse of the sine, which is the hypotenuse to opposite. We'll call that one cosec theta. So cosec theta is the inverse of sine theta. Then the inverse of cos is cos secant, that's sec theta. That's inverse of cos. Then the inverse of tan is called cot theta, which is 1 over tan theta. So aside from the Pythagoras theorem, we must know this relation. I'll call this one equation 1, and the whole of this equation 2. Then you have to know equation 3 also. And what was it? Anytime we divide sine by cos, we get tan. So tan theta is the ratio of sine theta to cos theta. Note this. Then what is cot? The inverse of tan. So from here it means cot theta is the inverse of this, which is going to be what? Cos theta divided by sine theta. I'll take this as equation 3. Then after this we are good to go to start trig 2. So next thing is, from this Pythagoras theorem, we have a squared plus b squared equals to c squared. We can decide to divide through by c squared. From here, it implies that a squared over c squared plus b squared over c squared equals c squared over c squared. So here I'll be having a divided by c all squared, b divided by c all squared equals to 1. What is a over c? Sine theta. So if you slot in here, we get sine squared theta plus what is b over c? Cos theta. You square it. So that's the first trig identity under trig 2. Now we can decide to divide through by, let's say, cos theta. So we have sine squared theta, cos squared theta over 1. Let's divide through by sine squared theta. After division from here, sine theta over sine theta is 1. What is cos over sine? Cos over sine is cot. Then it has squared. So 1 over sine is cosec, and it has squared. So that was cosec squared theta. So that's the second relation. Then lastly, coming back to this equation again, sine squared theta plus cos squared theta equals to, we can decide to divide through by cos squared theta this time around. Instead of doing sine squared theta, we divide by what? Cos squared theta, cos squared theta, cos squared theta. What is sine over cos? Sine over cos is tan. So here we have what? Tan squared theta plus cos over cos is 1 equals to 1 over cos is sec, and we are squaring it here, so it becomes what? Sec squared theta. So please note this. So this 1, 2, 3, this All this one joined together, I'll call it equation 4. I must commit this to your memory, you need it. Especially to prove some trigonometry identities, or to prove some trig equation, or to solve trigonometric equation. But before we solve question on this, on some proving and solving trig equation, let's look into trig graphs and special angles, quadrant and negative angles, and other things that are related. Let us take it from special angles. So for the basic trig ratios like sine, cosine and tangent, you must know the value of some angles by heart. What are the special angles? For sine, cosine and tangent, you must know sine 0, cos 0, tan 0. Same goes for 90, 30, 60, then 90. So what is sine 0? 0. Sine 90, 1. Sine 30, half. Sine 60, root 3 over 2. Oh, this one is 45. Then sine 45 is root 2 over 2. Cos 0, 1. Cos 90, 0. Cos 30, root 3 over 2. Cos 60, 1 over 2. Then this is what? Root 2 over 2. Then what is tan 0? 1 divided by 0 is 0. Sorry, 0 over 1, because tan is sine over cos. 0 over 1, 0. 1 over 0, amplifying. This divided by this, we are going to get 1 over root 3. While for this one, we are going to get root 3 over 1. And for this one, we are going to get 1. So these are the special angles. You have to know this by heart. And in our previous lessons, we already proved how all these angles are gotten. Let's try to show it again, very quick. Now, let's show it very brief. Let's suppose we have an equilateral triangle. So if triangle is equilateral, it means all the sides are equal. And all the angles should be 60, 60, 60. So suppose the sides are 2, 2, 2, 2, 2, 2. Now let's bisect this. After bisecting, this turns to 1, 1. And this angle turns to 30 degrees. Recall this is 60. This is 60. The whole of this is 60, which is what? 30, 30. So let's, and this is 90 degrees. So if you bring out this part, so for a right angle triangle, if one of the other angle is 30, then the third angle is 60. So this side is 2, this side is 1. So this third side is unknown, let's call it x. And according to Pythagoras theorem, the square of the hypotenuse, which is 2 in this case, is the sum of the squares of the other two sides. So 4 equals to x squared plus 1. From here, x squared is 4 minus 1, x squared is 3, then x equals to root 3. So I can replace x with root 3. So from this triangle, we can get sine 30, cos 30, tan 30, sine 60, cos 60, tan 60. So meaning everything here can be gotten from this triangle. Should we try it? Okay, let's try it. Let's try to move for sine 30. Or sine 30, all the sine. So opposite to hypotenuse. What is the opposite? If your angle is 30, 1, hypotenuse 2. That's why sine 30 is 1 over 2. Then let's check cos 60. If our angle is 60, this is the opposite. This is the hypotenuse. So what is cos 60? Cos is car. That's adjacent hypotenuse. So if this is our angle, this is now opposite. This always hypotenuse, this is now adjacent. So that's 1 over 2. Sine 30 and cos 60, they are the same. Why? Because these two angles are complementary. When two angles are complementary, the sine of one of the angles equals to the cos of the other. So same goes for sine 60. Sine 60 will be what? Opposite to hypotenuse. That's root 3 over 2. What about cos 30? This is 30. So they will be opposite. This is the adjacent. Cos is what? Adjacent to hypotenuse. Root 3 over 2 also. So sine 30 equals to what? Cos 60. Sine 60 equals to cos 30. And if we know sine cos, we know tan, we just divide sine by cos. Or we can get directly also. Let's just do for tan 60. So you want to do tan 60, tan is 2, opposite, adjacent. So it's 60, this is opposite, adjacent, 3 over 1. So just note from this triangle, we can get 30 We can get the trig ratio for 30, 60 for all the trig ratios. Now let's move to 45 degrees. So just note this triangle in case if you forget the table. How can we get 45 degrees? Let's consider a right angle isosceles triangle. If this is 90, the other angle will be 90 together. So if you divide them equally, that will be 45, 45. So it means this side facing this one and this also equal. So this is what we call right angle isosceles triangle. This side must be equal to this side. So if this side is 2, this must be 2. If it's 1, this side must be 1. So suppose this side is 1 and this side is 1. These angles are 45 degrees each. So if these sides are equal one over this side, let's call it x. X is the hypotenuse, x squared equals to 1 squared plus 1 squared. X squared equals to 1 plus 1, 2. Then x equals to 2. So we can replace x with root 2. So from here we can get sine 45, cos 45, and tan 45. So let's do sine 45. What is sine 45? So opposite over hypotenuse, 1 over root 2. What we cos 45? If this is the opposite, this will be the adjacent hypotenuse. Is still 1 over root 2. As you can see, they are equal. Why are they equal? Because these two angles are complementary. What we tan 45? Opposite to adjacent. If this is the angle, this is opposite, this is adjacent to 1 over 1, which is 1. So now I'm wondering, this 1 over root 2, why did I write 2 over 2 then? Because already for this one, we've rationalized it. This 1 over root 2, if we rationalize by multiplying by root 2 over root 2, we have a root 2 over 2. Same goes for this. Sometimes I not see 1 over root 3. Instead, you can see root 3 over 3. Why? Because if you have 1 over root 3, and we rationalize by multiplying by the conjugate, we get root 3 over 3. So that is for 45. So we are done with 30, 60, 45. What about 0 and 90? The simplest one. Consider this right angle. Let's suppose this angle is theta. And let's label this side A, B, C. Now, from here, what is sine theta? Sine theta is opposite hypotenuse, B over C. What is cos theta? That will be adjacent hypotenuse. What will be tan theta? Opposite adjacent. Now, from here, what will be sine 0? What will be cos 0? What will be tan 0? If you know sine, cos, you know tan, so I'll leave out tan. So what is sine 0? For this angle to be 0, what must happen? Look at this. This is theta. Theta is smaller. It's smaller. And as time getting smaller happen, this side is what? Is reducing. It was like this before, now like this, now like this. So it means if theta is 0, it implies that what this b will not be there again. It means b also will be 0. And in that case, if b is 0, this a and c will coincide. Then it implies that a will be equal to c. That's the condition. So sin theta is b over c. But what's our b this time around? Our b is 0. That will be 0 over c. So sin 0 is 0. What's cos 0? A over c. What's a? A equals to c. So this write a over c, write c over c, which is 1. So cos 0 is 1. Sin 0 is 0. What we tan? Just divide straight. That's all. So for it to be 0, that's the condition. Next thing, what about sin 90 and cos 90? So for our theta to be 90, if theta is 90 degrees, so this line, instead of this line to move down this way for theta to be 0, for this theta to be 90, we have to raise this one until it goes this way. Meaning we'll open up this and we'll be having something like this. If you open it up, this is still our A, this is C, and this is B. What happened? No line is here. So from here it means A becomes 0. A becomes 0. And what happens to C and B? C equals to B. So we'll come back, sin 90. Tan is B over C, B over C. What's our B now? Our B is C. So that's C over C. So sin 90 is 1. How about cos 90? Cos theta is A over C. What's that? A is 0. That's 0 over C. That's 0. That's why cos 90 is 0. Cos 90 is 0. And sin 90 is 1. Sin 90 is 1. Okay, let's do tan. Let's do tan straight. What will tan 90? Tan is B over A, right? B over A. What is our A? Our A is 0. B over 0 is what? 25. You can also do for tan 0. Tan is B over A. B over A. What is B is 0? That's 0 over A. It's also what? 0. So we are done with all the special angles. You have to know all this by heart. There are many ways of memorizing this. There are many methods online, yes. But I believe it's easier for you to memorize it. Shortcut. If you know sin 0, you already know sin 90 cos 0 cos 90 tan 0 tan 90. How? Sin 0 is 0, then sin cos 90 must also be what? 0. So cos 0 be 1, sin 90 be 1. To get tan, you divide, finish. If you know sin 30, you already know others. You know 30 and 60 already. Because sin 30 and cos 60 will be the same. Half half. So cos 60 will go to 3 over 2, sin 30 will be 2 over 2. Sorry, cos 30 will be 3 over 2. Then sin 40 and cos 40 they are the same thing, 2 over 2, 2 over 2. So I prefer you memorize it to be quicker than you trying to look for any method to use to recall. Now let's move to quadrant. So what is the quadrant? A quarter of a circle. Consider this circle. Here we have 4 quadrants. First quadrant, second, third, and the fourth quadrant. Suppose we have the radius of this circle drawn from this point to a part of the circumference. So you can join any part here. So obviously, this particular radius made an angle to this horizontal line. So let's draw this vertical line down here, which will be the opposite to this angle theta. So here, this is the opposite, let's call it A. This is the what? Adjacent, let's call it B. And this is the hypotenuse, let's call it C, which is the radius. So from here, obviously, if this is the Cartesian plane, you know Cartesian plane has y-axis and x-axis. So this side is positive x, positive y, this negative x, this negative y. So here, the value of b is positive x, a is along positive y. So if we do sine theta, what sine theta? Opposite to hypotenuse, a over c. If we do cos theta, that's adjacent to hypotenuse, b over c. And if we do tan theta, we are going to get what? Opposite to adjacent, that's a over b. And in these three cases, since a, b, c, they are all positive here. No, the radius is always positive. A and b changes. So it means everything here will be positive. So in the first quadrant, sine of this angle, cos of this angle, and tan of this angle, they are all positive. Why? Because the angle still falls within the first quadrant. So this angle here is an angle that falls in the first quadrant. Now let's draw an identical triangle, but to the second quadrant now. Let's draw an identical triangle here. So meaning, if this is B, this is also B. But note, this is negative what? X. So this is going to be negative B. So let's draw the radius to a point such a way that the height will remain same thing as what? As A. So the value of B is negative because this falls to negative X. But A is still above, so it's still positive A. Now if this angle is theta, the angle in first quadrant theta 1. So this angle is still our theta 1. But what happened here? We've shifted the angle. You know, we started from here to here. But this time around, we're moving from where? We're moving from here to a new place. So we always take the angle from this point to touch the radius. This time around, the radius falls here. So we take the angle from, let's say, this same point to here. So this angle is angle that falls in the second quadrant. And something is obvious here. We can write this angle inside. For example, total angle on a straight line is 180. So this theta 2 plus theta 1 will give us 180 degree. So for me, it means theta 2 equals to 180 degree minus what? Theta 1. So angle in second quadrant is 180 minus the angle in the first quadrant. Now, if you observe, A is still positive, C is still positive, but B is not negative. If B is negative, what will be affected? Cos and tan will be affected because they both have BB. So what happened? Cos and tan will be negative, but sine remains what? Positive. So this implies that sine theta 1 in first quadrant will be what? Sine theta 2 in second quadrant. They will have the same value. But cos theta 1 in first quadrant will be equals to what? The negative of cos theta 2. Same thing goes for tan. Tan theta 1 will be equals to what? Minus what? Tan theta 2. Or we can bring negative to the other side. So we can say sin theta 2 equals to sin theta 1, cos theta 2 equals to negative cos theta 1, and tan theta 2 equals to what? Negative tan theta 1. Why? Because B becomes minus in the second quadrant. So this is what happens in the second quadrant. This might look confusing, but for you to understand it better, let's take an example. Note this. All these three angles, they are in second quadrant. Note, theta 2 in second quadrant is not up to 180, but more than 90 degrees. So angle in second quadrant falls between 90 and 180. So here we are told to look for the sine 50, cos 135, tan 120. Without calculator, what are we going to do? So we come to the solution. Angle in theta 2 is equivalent to 180 minus angle in theta 1. So meaning I can write it as what? Sine 180 minus what? 150. This is what? Sine 180 minus 150. Why this will be equals to cos 180 minus 150. Sorry, 135. And this one will be what? Tan 120. Sorry, 180 minus 120. Or better still, maybe we should make theta 1 the subject. Because most times we want to write our angle in first quadrant, in acute angle. If you make theta 1 the subject instead, it means theta 1 will be equals to 180 minus theta 2. Let's put it that way. Because our aim is to express it in what? In theta 1. Is to express theta 2 in terms of theta 1. So, if you know this, we are good to go. Because this is theta 2, theta 2, theta 2. So if you remove theta 2 from 180, you get what? Theta 1, theta 1, theta 1. Because at the end, this will give us what? Sine 180 minus 150 is 30. So some 150 and 30 they are equivalent. And this will give us what? Cos this 135. That's cos 45. And this will give us tan 60. They will have equal magnitude, but the sign might change. So that is why this is useful. In second quadrant, cos and tan are negative. So meaning the answer here is going to be negative. But sine is always positive, so the answer here is positive. So at the end of the day, we are going to get our sine 150 to be equals to what? Sine 30? Half. The special angle. That will be what? Plus half. That's the answer. Then our cos 135 will be equals to negative cos 45. That's minus what's cos 45 special angle? Root 2 over 2. Then lastly, tan 120 is same as what? Negative tan 60. What is tan 60? Tan 60 is root 3 over 1, that's root 3. So the answer is negative what? Root 3. So note, in first quadrant, all are positive. In second quadrant, only sign is positive. All positive, only sign is positive. What happened to the third quadrant? No, I'll still summarize everything together. So let's extend this line this way and draw radius. So this will remain B, our A will be down here. Then the radius. Now this is A, but this is about an A falls to negative Y, so this is minus A. So this triangle now, this is minus B minus A. C is very constant. So first, let's talk about the angle. You have to shift from this point to here, to this line. From here to this line. Let me use another ink. So from here, we'll go and come here. That's our theta 3. This always what? Theta 1. Something is obvious here. From this point to this point is 180. If I remove theta 1, sorry, if I add 180, this is 180. If I add theta 1 plus 180, I'll get theta 2. Sorry, theta 3. So theta 3 equals to 180 degree plus theta 1. So that's relation for the third quadrant. So sin theta 3 equals to sine, okay, let's put it here straight. It's equal to sin theta 1, right? And how do we get this theta 1? We add, to get sin theta 3, we add 180 to sin theta 1. Let's make theta 1 the subject. If you make theta 1 the subject, so theta 1 equals to theta 3 minus 180. So theta 1 equals to theta 3 minus 180. So we have angle in third quadrant. For us to express as angle in first quadrant, we remove 180 from it. So sin theta 3 can be equivalent to sin theta 1. Same goes for cos and tan. The significance of this means that any angle in third quadrant can be expressed as angle in first quadrant. Any angle in second quadrant can be expressed as angle in first quadrant. But the only thing is that the sign will change for some. How are you to know the sign of A and B? So A is negative, B is negative. If A is minus and B is minus, if you come here, A is minus 6 always plus, so it means our sign will be negative. Why? Because A is minus. For cos, it's also going to be negative. Why? Because B is minus and C is plus, so cos is also negative. But tan will be positive. Why? A is negative, B is negative. Negative cancel negative, so tan is positive. So this means that in the third quadrant, only tan is positive. Let's take examples on this. So look at this. 240, 210, 225, they are all angles in third quadrant. Why? Angle in third quadrant theta 3, they are not up to 70, but they are more than 180. So these are angles in third quadrant. So first quadrant angle, theta 1, they are less than 90, but more than 0. So first is to identify what quadrant do those angles fall into. Always the angle fall in third quadrant. So in third quadrant what happens? Sine is negative, cosine is negative, tan is positive. Then express this 240 as angle in first quadrant using this formula. Meaning from that angle we remove 180. So if we remove 180 from 240, we get 60. So 240 is same as negative what? Sine 60. So same thing. We want to write 210 as angle in first quadrant. So we are going to remove 180 from 210. That will be cos 30. Then for tan, remove 180 from 255, we get what? 45. That's tan 45. So what's the answer in each case? So sin 60 is what? Root 3 over 2. Cos 30 is what? 1 over 2. Special angle. And tan 45 is what? 1. So special angles are important, but if you have angles that are not really special, like for example, when you look at 240, 210, 225, 150, 135, 120, they don't look like special angles, but they are what? Special angles when you take them to quadrant. When I'm done with this, I will summarize everything again. So what about the third quadrant? So if first quadrant all is positive, second quadrant sine is positive, third tan is positive, the fourth quadrant definitely what will be positive? Cosine will be positive there. Let's show it. Let's draw an identical triangle here. So this still remains B. So let's draw our A here, and this will be the radius R, which is C. So what happens here? Our A falls down, so A is negative, B is positive. So this is still our angle theta 1 here. What happened to theta 4? For theta 4, we start from here, we move until we touch this line. So this is theta 4. So theta 4 plus theta 1 will give us 180. So that was fourth quadrant. Where should I write down? Let me write down here. So for fourth quadrant, what happened? Theta 4, do all of this, plus theta 1 equals to 360. Note our aim is to always get the answer in theta 1. So theta 1 equals to 360 minus what? Theta 4. So any angle in the fourth quadrant can be expressed as angle in first quadrant by moving the angle from what? 360. So now what happened here? What happened to sine, cos, and tan? What happened to their sine? So what happened to sine? For sine, here, for sine it is A over C and A is negative. So sine will be negative. For cos, it is B over C, but B is positive here. B is positive. So that will be positive B over C, positive. For tan, A over B, A is negative, so tan will be negative. So it means sin theta 3 is same as what? Minus sin theta 1. Cos theta 3 is what? Plus cos theta 1. Sin theta 3 is what? Minus tan theta 1. This is for what? For four quadrants. This is for second, third, fourth quadrant. So in fourth quadrant, only cosine is positive. Let's summarize this. Let's summarize, and I believe the summary will be more understanding than the explanation itself. All right, look at this acronym. Cast 4, 1, 2, 3. This means in the first quadrant, all are positive. Second quadrant, only sine is positive. Third quadrant, only tan is positive. Fourth quadrant, only cos is positive. And note, angle in second quadrant equals to 180 minus what? No, angle in first quadrant can be expressed as 180 minus angle in second quadrant. Angle in first quadrant can be expressed as what? 180. Sorry, theta 2 minus 180. And angle in third quadrant can be expressed as angle in first quadrant by removing that angle in third quadrant from 360. So note this. The summary is first note this, then note this. And I think that's all. With this, we are good to go. Now, let me give the last example. Note, I made a change here. Now, we have to solve this without calculator. First is to identify which angle it falls to. Recall, theta 2, theta 3, theta 4. They have the following range. Now, 3 over 5 falls in what range? It falls here. So I'm going to write this equals to, what do we do in fourth quadrant? We remove the angle from 360. That what? Tan 360 minus what? 315. Next, what will be sine? In fourth quadrant, what happens? In fourth, only cos is positive. So this tan what? It should be negative. So that's minus tan 45. And that's what? Minus special angle. Tan 45 is 1. So tan 315 is minus 1. Over cos 300. 300 falls in what quadrant? It falls here. This should be, what am I writing? This is 360. And this is 270. So 300 falls in between. That's the fourth quadrant. So in fourth quadrant, we do what? We subtract the angle from 360. What about the sine? In fourth quadrant, cos is positive. So positive plus cos 60. And what's cos 60? Cos 60 is what? Special angle. 225 is not here. 225 is in third quadrant. So what happens in third quadrant? We remove 180 from the angle. From the angle, we remove 180 from it. And what will be the sign? In third quadrant, only tan is positive, so this sign will be negative. So that's minus sine 45. That's minus what sine 45? 2/2. The last one cos 120. So 120 falls here between this. That's second quadrant. What happens in the second quadrant? We'll remove the angle from 180. So this cos 180 minus 120. What happened in first quadrant? Sorry, second quadrant. Only sine is positive, so this cos is negative. Minus cos 60. And cos 60 is half. So I think with this summarizes everything I explained earlier with these examples. Now let's work trig graphs. Suppose we have a trig function y, which is a sine function. Let's call it sine x. Or let's say sine theta. So if you take several angles for x, let's say from 0 to 360, how will the graph look like? So there is everything our y, which is sine x. So let's take theta from 0 to 360. So this 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. You can write everything. So sine 0 is 0. Sine 90 is 1. Sine 180 is 0. Sine 270 is minus 1. Then sine 360 is 0. So if you have to join, here we have maximum point here we have minimum point here. You have a graph that looks like this. This is what a sine graph looks like. So you can plot all the points together. So this is 30. You bring it here, you get half. This is 60. You bring it here, you get root 3/2. But in short, this is how a sine graph looks like. Y equals sine x. So a sine that look like this, note that it's a sine graph. But this can take a coefficient, maybe 2 sine x. So if it's 2 sine x, this graph gets longer. So instead of having something like this for sine x, for 2 sine x, you can be having something like this. It has higher amplitude. So the more the coefficient, the more the amplitude. That's y equals half sine x. You get what? Smaller, something like this. So you get different graph depending on what? On the coefficient. And also the sign. If this is negative, what happens? This goes down before coming up. If it's minus sine x, then our x can also change. You can have 2x. If I have 2x, what happens? There will be a what? A shift on the x-axis. If you have half x also, there will be a shift on the x-axis. But basically, all sine graph looks like this. Especially if they have no intercepts. Maybe you're not adding, if you are adding, let's say 1 or 2 to it, it will shift up or down. But basically, this is the sine graph. Let's take cosine graph. 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Let's show the mini point. Cos 0 is 1. Cos 90 is 0. Cos 180 is minus 1. 270 is 0. 360 is 1. So if you join all the points together from here to here to here to this, the cos graph looks like this. Just note when the graph starts from the amplitude back to negative, back to the amplitude, it is what? Cos graph. So sine graph starts from the origin. Cos starts from what? 1, the highest value. So this is for what? Y equals to cos x. This y equals to sin x. We can actually show for other graphs too. Let's do y equals to tan x and see what we are going to get. 30, 60, 90, 180, 270, 360. If you are sketching, it's better you put all the values from 30, 60, you plot the point. You can use your calculator, use special angles or quadrants, you get the values, then you plot your point together. But you should know that tan 90 is undefined. So tan graph looks somehow, but not too bad. It looks beautiful actually. So tan 0 is 0, tan 30 is smaller than tan 60. So meaning you are going to have a graph that will move from here, from this 0 to infinity. What will happen next? Tan 180 is 0. Let's pick a value between this 120. Tan 120 will give us negative tan 60 somewhere here. Let's now put a value close to 180. Let's say tan 150. That will give us a positive value. So what happens? We are going to have a graph. This will continue like this. Is it not beautiful? Let's continue. Out of 70 you have 300. What is tan 300? It is negative root 3. So it's somewhere here. Okay, what about tan 330? So that's negative 30. It's still somewhere here. So it's growing. What about tan 360? It is 0. So meaning I'm coming from here. Then we'll click here also. So that's for what? For graph of tan from 0 to 360. If you have to move above 360, the graph will continue. Then we are going to have something like this. To continue that way. While this one, if we go to negative side, to continue this way. Can you see? It's like we're having S. Shift. S 180, S 180, like that. For this one, it has this pattern, which you can also continue. If we continue this, we're having something like this. What about this one? We have something going this way. So that's how it's going to continue. For sine, it also continues that way. But focus on the red line when the angle is taken from 0 to 360. Now let's talk about negative angles. What do you mean by that? We know sin x to be opposite over hypotenuse. But what's the value of sine minus x? What's the value of cos minus x? The value of tan minus x. We can also actually get that from the graph. So instead of using 30 to 360, let's now use minus 30, minus 60, minus until we get to minus 360. If you move backward, what are we going to get? So the values we're getting in each case, for sine minus x will be what? Negative of what? Sine x. But cos minus x is still cos x. Is also negative, will not affect cos. Why tan minus x is negative what? Tan x. So I think what is most important is to know that sine minus x is what? Minus sine x. Tan minus x is what? Minus tan x. But for cos, is the only one that is different. So if you go ahead and press to cos minus 60, you are going to get half. But if you press tan minus 60, tan 60 itself is root 3. This one you are going to get minus root 3. Then if you press sine minus 60, sine 60 is root 3 over 2. Yeah, you are going to get minus root 3 over 2. So, meaning it is only cos that doesn't follow the pattern. The cos of a negative angle, the cos of a negative angle is same as the cos of the positive of that angle. The question is, why is cos different? You can actually show that from the graph. Look at this. Cos 0. But if you check cos 90, see the value here. Cos minus 90, see the value here. Okay, let's press cos 180, see the value here, negative 1. Over cos negative 180 is still what? Minus 1, if you draw it right. So, it goes hand in hand. It's symmetrical. But for this one, look at sine 90 here, 1. Look at sine minus 90 here, minus 1. It's negative. Same thing goes for tan. Look at tan 90 is rising up, positive. Here, tan 90 is what? Going down, negative. So you can show that from the graph. That cos of a negative angle is what? Cos of the positive angle. This is the end of trick 2. The only thing we have to do is to solve question on this. Then move to trick 3. In trick 3, we focus on compound angles, double angles, triple angles, half angles, product to sum formula, and sum to product formula. In trick 1, we did sine rule, cosine rule, trig ratios. We solve question on right angle triangles, angle of elevation and depression, bearing and distance. So after solving question on this, our next lecture will be trick 3. We'll solve question on that, and that will be the end of trigonometry for O level.